When learning about electricity, terms like volts, amperes, and watts come up. Can you explain them in an easy-to-understand way? The concepts of volts, amperes, and watts are fundamental in the study of electricity. Volt, is the unit used to measure voltage in an electrical circuit. Voltage refers to the level of electric flow, and higher voltage means more electricity is flowing. Ampere, is the unit used to measure electric current in an electrical circuit. Electric current represents the amount of electricity flowing, and a higher current means more electricity is flowing. Watt, is the unit used to measure electrical power in an electrical circuit. Power is calculated by multiplying voltage and current, and higher power means more electricity is being used. These concepts are interconnected, and understanding them is crucial in knowing which components to use in an electrical circuit and how much electricity is being consumed. For example, when using a light bulb or a computer, you need to consider the required voltage and current of the device and calculate the resulting power. I would like to know the principle of a generator. Does it create electricity using kinetic energy to generate a magnetic field? The principle of a generator is to convert mechanical energy into electrical energy. Typically, a generator consists of a rotating magnet and a stationary electromagnetic coil. The rotating magnet creates a magnetic field. When this magnetic field passes through the stationary coil, electrons within the coil start to move. This movement of electrons is then converted into electrical energy. For the electrons to move within the coil, there needs to be interaction between the electrons and the magnetic field. To achieve this, the magnet and the coil are designed to interact with each other. As the magnet rotates and changes the direction of the magnetic field, the movement direction of the electrons within the coil also changes, resulting in the production of electrical energy. The principle of a generator is utilized in various applications, ranging from the charging systems in automobiles to large-scale power plants. Additionally, generators can be used to charge energy-storing batteries. So, is the movement of electrons what constitutes electric current? Yes, that's correct. In the process of generating electrical energy, when electrons move between the magnet and the coil, electric current is created. The current flows in the opposite direction to the movement of the electrons. This electric current can be used to power electrical devices or store electrical energy through a circuit. The unit of current is measured in amperes, A, and the magnitude of the current is determined by factors such as the speed of electron movement, the number of electrons, and the material within the circuit. Then where do these electrons come from? Are they bouncing off the coil's metal due to the magnet's movement? The electrons are not already present within the coil's metal. They are set in motion through electromagnetic devices inside the generator. Typically, a generator consists of a rotating magnet and a stationary coil circuit. As the magnet rotates, it creates a magnetic field, and when this magnetic field passes through the stationary coil, the electrons within the coil start to move. This movement of electrons is then converted into electrical energy. Therefore, the electrons move within the generator through the interaction between the magnet and the coil. To induce the movement of electrons, an external energy source is needed in the entire circuit to create a flow of electrons. This external energy source can be the mechanical energy of the generator's rotation. In summary, a generator generates electrical energy through an electromagnetic device comprising a rotating magnet and a stationary coil. Electrons move within the coil due to the magnet's movement, and this movement results in the production of electrical energy. So, when I pedal a bicycle, electricity is generated and the front light receives power from it. Is it because the coil and magnet inside the generator convert the rotational energy from pedaling into light in the bulb? Yes, that's correct. The electricity generated for the bicycle light when you pedal is utilizing the principle of a generator. The bicycle light has a built-in generator, which consists of a rotating magnet and a stationary coil. As the bicycle wheel rotates, the magnet and coil within the generator also rotate, generating electrons and producing electrical energy. Therefore, the electricity generated for the bicycle light is the result of converting the rotational energy from pedaling into electrical energy through the coil and magnet inside the generator, which then powers the bulb and produces light. This principle is used not only in bicycle lights but also in various applications, and it is employed to generate electricity in power plants using a similar principle.